This is Chapter 9, Lesson 2, Theoretical and Experimental Probability. So we've already talked about simple probability. And now we're going to stay on that same theme, but we're going to be comparing two different types of probability. And really, I think the terminology sounds a little bit more complex than really what it is. Theoretical probability is what should happen when you're conducting some kind of an experiment. And then the experimental probability is what actually occurs. Sometimes those things will be the same thing, but they won't always happen that way. Here's a good example. In lesson 1, I talked about flipping a coin, and you have a 50-50 chance, which means that if you flip a coin, it should land heads, followed by tails, heads again, followed by tails, and that pattern would continue to repeat over and over and over again. But that's not always the case. You might flip and get tails 3 times in a row. So what is expected to happen doesn't actually always occur. And in this lesson, we're really going to be working on comparing those two. So we're going to jump right into our examples here. Example 1, the graph shows the results of an experiment in which a spinner with 3 equal parts is spun 60 times. So, and if you look over here, it says that 21 times it landed on green, 15 times it landed on blue, and 24 times it landed on red. The question then asks, find the experimental probability of spinning red for this experiment. So we know that that occurred 24 times. Now we just need to know out of how many total times, and we do know from the information that it is 60. So we don't even really need, well, I guess you do kind of need the chart here, but really just the 24 and the 60 are the only numbers that we need. And so we would write that as a ratio of 24 over 60. And just as in lesson 1, we need to reduce that into lowest terms. So if I move this on, you can see that 24 over 60, both I can divide those by 12. I could also divide them by 2 and just keep reducing that way. And then in lowest terms, it would be 2/5. So the experimental probability of landing on red is 2/5. But we're going to change this question for the next example here. And it says, compare the experimental probability you found in example 1 to its theoretical probability. Well, we know that there are 3 equal sections. It says that in the previous problem, that they are equal sections on the spinner. And so kind of just picturing what this would look like, you would have a circle with 3 equal parts that exist in that. So that being the case, like we should have an equal chance to land on each one of these. So if you look at what it says here, the theoretical would be an equal amount for each one of these, which would be 20, 20, and 20, because that together, 20 plus 20 plus 20 would give you 60, because each one of them have an equal amount of chance. So the theoretical probability is 20 over 60, which is 1/3. So if we compare those two, we would see that from our first example, the probability was 2/5. The probability for the theoretical probability is 1/3, which those are fairly close together. If I actually made common denominators here, you would see, what would this be? It would be, the common denominator would be 15, and this would be 6 over 15, and this would be 5 over 15. So which those are only have one numerator difference. They're 1/15 off of each other. So they're very, very close in value. You can see even the green, it should have occurred 20 times and it occurred 21. So it's even closer to that experimental probability. And then blue was a little bit low, right? That should be 20 out of 60 as well, but it occurred 15 times, so it occurred less. So that's kind of really what we're doing in this lesson, is comparing theoretical and experimental probability to each other. All right, one more example we're going to look at here. This one's a little bit interesting because you're going to have to use our knowledge of proportions to solve that. So let's read the problem first. It says, last year a DVD store sold 670 action DVDs, 580 comedy DVDs, 450 drama, and then 300 horror DVDs. A media buyer expects to sell 5,000 DVDs this year. Based on these results, how many comedy DVDs should she buy? And then we're supposed to explain the answer. So if we look at this, we have to really kind of come back to this idea about comedy. Well, there's 580 that were sold out of a total amount. So if we totaled up 670, 580, 450, and 3000, we would see how many total DVDs were sold. So when I add those together, I'm going to go ahead and advance the slide, that would end up being 2,000 when I add all four of those numbers together. 2,000 DVDs were sold total. 580 of them were comedies. So we put 580 over 2,000, and then this is where we use the proportion. We set that equal to X over 5,000. So a good way to think about this is that more DVDs are going to be sold in this next year, right? It was 2,000 DVDs that are sold. They're now projecting that business is going to improve and they're going to sell 5,000. So we would expect kind of all of these numbers to go up, but we're really only focusing on what happens to the comedy DVDs. So it's X over 5,000, and that's going to allow us to see what ends up being our answer here. So we use cross multiplication. 2,000 times X is 2,000X, and then 580 times 5,000, that's where I cross multiply, and we get a rather big number here. What is that? That's 2,900,000, and then we divide by 2,000. Often with probability, you don't really think about too much about using a calculator, but I think that would be really helpful here. And so when we divide that, we get 1,450. So that's the projected number of comedy DVDs that would be sold if 5,000 DVDs are going to be sold. So we're kind of using what is a previous experiment, basically like the business existed and this is how many DVDs were sold, to project what would be the probability for the future. So it's kind of an interesting problem in the way it's worded. So you will have to use some proportions on your assignment today. So keep in mind when it's asking for experimental probability, it's the actual thing that occurs, and theoretical, reviewing back over, theoretical is what should happen. Sometimes those could be the same things. Often with this assignment, you're going to see that those are different from each other. So that is the end of this lesson. Again, like always, you're going to look at the homework assignment that's on Google Classroom and then answer those questions in the Google form and then submit that, and you'll get your results to see how you did on the assignment. Thanks for watching Lesson 2.